Okay, and welcome to the first lesson of Chapter 7, all about polygons. The diagonal of a polygon is a segment that joins two non-consecutive vertices. So if we have a few-sided figure here, guys, remember polygons are enclosed figures. Okay, here's a figure here, A, B, C, D, E. So this is a five-sided figure here. 1, 2, 3, 4, 5. Pentagon, right? The diagonals of this pentagon would go from B to D or B to E. They're not one after the other. So B and C make an edge of the polygon, not a diagonal. So those two would be diagonals. Okay. This is the big theorem we're dealing with today. Okay? We would say the sum of the measures of the interior angles of a polygon can be created by this formula here. We would go n minus 2 times 180. That tells you how many degrees the total polygon is going to end up to be, okay? So in example 1, find the sum of the measures of the interior angles of the figure. We first got to figure out what kind of a figure this is. So we got to count the sides. So we've got 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. Let's just spell it. I couldn't remember if it was octo or octagon. Octagon. Ooh, I should do a code word. We'll say red banana. That's the code word. If you've watched this video, you should have red banana written at the top of your worksheet. All right, so this is an octagon. That means our n is going to be 8 because we have 8 sides. So we're going to put an 8 into our formula. We're going to go 8 minus 2 times 180. 8 minus 2 is 6. 6 times 180 gives me 1080. And we can't forget to put degrees after. Make sure you put degrees because that is the unit of measurement here. And that's it. You just got to find your sides, plug it into the formula, easy peasy. Now you guys are also going to have to work backwards. So they will tell you what the angles add up to be, and then you got to figure out the side of the figure. But that's easy. You're just going to say, well, we would have gotten 900. And you got some options. We could either distribute that 90 there. Yep. We could either distribute the 180, or do you guys see how you're just multiplying n minus 2 times 180 and n minus 2 is in parentheses? We can just divide it out right away. Make our life so much easier. And we end up with 5. 9b divided by 18 is 5, so 900 divided by 180 is also 5. So we'd say 5 equals n minus 2, and then we would just add 2. So we get 7. So this was a 7-side figure, which is a heptagon. 7 sides heptagon. Okay. Heptagon. We got to remember all of our gons and our... So remember, we have a triangle is our three-sided figures. Then we have a quadrilateral, which is our four-sided. We got pentagon. We've got hexagon. Let's try. So we've got triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. We'll just stop there for now. It goes up a little higher, but whatever. We're good. We got what we need. All right. In geometry, we got to prove things forward and backwards, right? And that's the polygon. Okay. So this one, as like a offshoot, they made a separate little theorem since quadrilaterals is such a big encompassing heading. There's a lot of figures that have four sides. Apparently that was important enough to get a corollary. So we would say the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So if you ever have a quadrilateral, you can just go ahead and make it equal 360 right away. So in this one, we want to find the value of x. We can make an equation. We can subtract stuff from 360, whatever. But we'll just show you with an equation here. So what we would do is we would take all of our angles up and we would set them equal to 360. It's just like that triangle stuff, only we're doing it to 360. And then we're going to combine our like terms. So when we add those together, we would get 288. And then we're just solving. So we get x is equal to 72. So it says find the value of x in the diagram. It doesn't really say find the missing measure. It is the missing measure, but you would just say x is 72. You don't necessarily have to put degrees in that one because we're answering the question. So then we're going to get into equilateral and equiangular and regular stuff, just so you guys are aware of how we're defining that. In an equilateral polygon, all sides are congruent. And that's just like an equiangular polygon. We would say all the angles are congruent. And an irregular polygon is both... It is equilateral and equiangular. It is very, very common for a figure to be referred to as a regular polygon. So you guys got to know that that means everything is the same. In this example, they want to know a home plate for a baseball field is shown below. Is the polygon regular? Well, polygon, for it to be regular, has to be equiangular and equilateral. And we can see that It looks like it's got 3 90-degree angles, but it definitely has 2 obtuse angles. So we would say no, because it is not equiangular. And you guys know if it's not equiangular, it's likely not equilateral. But equiangular is the one that we are given. The angles are not the same. Then it says it wants us to find the measures of C and E. Well, we can do that, right? Because we know it's a 5-sided figure. So it's got 5 sides. So if we plug the 5 into our formula here, we get 3 times 360, which tells us that it's going to equal 540 degrees. So then what we can do is we know 3 of those angles are 90. And we know these 2 angles, E and C, are going to be the same. So we can make that the same variable. So we can make an equation here. We can say x plus 3 90s, right, would equal 540 degrees. So then when we combine our like terms, we're going to get 2x plus 270 equals 540. Then we got to subtract our constant. So we get 2x is equal to, oh, they didn't. Okay, so we get 314, so we get 140 there. Nope, 170. There we go. That, what? The book is doing something weird. Hold on, friends. Hold on. I will grab a calculator and not just go off of the book. See? Don't trust the book. Okay. So we would go 540 minus 270. There it is. Oh, jeez, guys, it's early. Early. So let's just try this again. 2x plus 270 equals 540. Wow, okay. Yeah, feel free as proof that you've watched this video to, I don't know, make me aware of that wonderful whoopsie in math. And then we're going to divide by 2. So we get x is equal to 135, I believe. Yep. So that would be the measures of C and E. So we would say they want the measures of C and E. We would say the measure of angle C and the measure of angle E equal 135 degrees. Okay? I like these problems because they all kind of build on each other. Oh, come on. All right. Last thing is these exterior angles of a polygon. We love exterior angles because all of them equal 360 no matter what. Because if you kind of draw the exterior angles of a polygon and you extend out the sides, you'll kind of see what figure they make. So let's kind of take we'll take a pentagon here. And if we did that where we extended the sides out, each side, right, to get exterior angles, that's why we would do this. Look at what happens when I draw something around. We get a circle. So we would say the sum of the measures of the exterior angles of a polygon is, So the way they measure it, they measure one angle at each vertex, and it is important to note that, because if we extended them out all the way, then you would see technically there could be two, but we would say one angle per vertex is 360. Whenever you see exterior angles, they usually look like this picture here, okay? So again, it's the same thing. Those are angles on the outside of the polygon. So all we're going to do is we're going to add them together. And we don't have to worry about what they're going to equal this time, because they will always equal 360. So then we're going to combine some like terms. And then we got to solve here. And then divide by 3. So you get 68. And they just want the value of x. So you would say 68. Does not have to be degrees or anything. All right. So a trampoline is shaped like a regular dodecagon, 12 sides. So if you want to try to draw that, you go right ahead. I'm not going to do that. We want to find the measure of each interior angle. So we're going to start with, and we know it's regular, so all of the angles are the same. And they want each interior angle, so that means they want one angle. Okay, so each means one angle. So we're going to start with our formula, 12 minus 2 times 180. So we're going to go, and I'm going to plug it right into the calculator like that, because I like less work. 1800 degrees. So that is what all of the measures. Now what I'm going to do to figure out the one angle is I'm going to take 1800 and I'm going to distribute it evenly amongst the 12 angles. So we get each angle, the measure of the angle, I don't know, we could say measure of one angle would equal 150 degrees. And then the exterior angle, we don't have to do that little formula because we know all exterior angles are going to equal 360. So all we got to do is do 360 and divide that by 12. 360, divide that by 12, and we get 30. So that's it. Just be aware of the word each. Each tells you got to do the division. That's it, friends. Happy worksheeting.